This part of the problem actually provides us with a new function. This function p of x here, which is 40 minus 2x plus pi x, which represents the perimeter of the shape after the semicircular opening has been removed. We're going to use this information to answer the following questions. Okay, so questions parts E and F. Part F, it says, what is the average rate of change? And I always get excited when I see this because I know what to do. This is just the slope of p of x from the values of x 3.1 to 3.2. Okay, we're going to explain the meaning of the answer in this context, in the context of the problem. But let's first start by finding out what is the average rate of change. Okay, so I'm using this abbreviation, the average rate of change, which I know is a change in y over the change in x. Or in other words, what is the change in the output compared to the change in these two inputs here? Well, we are going to find the output at this point here, 3.2 first. So p of 3.2 minus the output at the initial point 3.1, and then divided by the difference between these 2 points. 3.2 minus 3.1. Okay. Now, all I'm going to do is substitute 3.2 into every value of x into this function p of x. Okay. Once I do that, you could stop the video and find out for yourself. This will give you 43.653. Okay. Likewise, I'm going to plug in 3.1 into every value of x into the function p of x, and I will get 43.539. Okay. I'm dividing by the difference between 3.2 and 3.1, which is 0.1. Once I do the calculation in the numerator, I will see that that difference is actually 0.1141 divided by this 0.1 here, which when I divide the two, I get 1.141. And that is the average rate of change. The only thing now that I need to do is indicate what are the units. Well, in the numerator is this this function p, which is the perimeter. Okay, is the difference between the perimeters, and the perimeters measure in meters. Likewise, in the denominator, I'm measuring the change in x, which is the change in radius, which is also measured in meters. So the average rate of change here is 1.141 meters per meters. Okay. Now, to explain the meaning of the answer in the context of the problem. Okay, very important. Now, what does that mean? What just happened? Well, what we did was we looked and see what happens when we change the input between 3.1 and 3.2. So I'm going to write that by increasing the radius of the semicircle. Okay, from 3.1 meters to 3.2 meters. The perimeter, and that's what's changing, the perimeter. Okay, so the perimeter, what happened to the perimeter? Well, the perimeter is increasing. Okay, increase by what amount? Well, it increased by this amount, 1.141. Okay, so it increased by 1.141. And that is all. That's all we need to really say about this when we are explaining the meaning of the rate of change or the arbitrary change in the context of the problem. Okay, on to the last question. F. F says, for what values of x will P of x satisfy the inequality P of x is greater than 45? Okay, so I'd like to write it down here. P of x is greater than 45. Okay, but what was P of x? P of x was this function 40 minus 2x plus pi x. We want that function to be greater than 45. So what I'm going to do, and you won't be able to, I won't be able to show you this using my calculator, but I just walk you through. So what I did was that on my calculator, so on your calculator, and you could try this as we go, we are going to, into this, the y1, I'm going to graph this function 40 minus 2x plus pi x. Okay, so 40 minus 2x plus pi x, I'm going to graph that into my calculator, into your window, if you will. You could do this manually as well, if you like to do it manually, just by using inverse operations and so on, but let's just go with this. y1 is 40 minus 2x plus pi x, y2 is 45. So once I graph it, okay, so graph these two functions on the same window and find the intersection point. Okay, if you find the intersection point, and actually when you graph it on the same window, you will get something that looks like this. I mean, I'm just going to sketch it real quick. This function is just a linear function, so it would look something like that. 40 minus 2x plus pi x. And you have this function 45, so you know that's just a constant function. And we are looking to find this point, the point of intersection here. And using this idea that this has to be greater than 45, I'm interested for every value that is beyond that point. Okay, if you do that, you get that x is approximately 4.379. Okay, it's approximately 3.79 or 4.380. Okay, now that is the intersection point, like we said before. Since I want the values to be greater than 45, I'm looking for every value beyond that point. Okay, but be careful. Okay, we know that we need a value for x that is greater than 4.379. Now, can I input any value for x beyond that point? Or in other words, would this be to infinity? And the answer is no, because we came up with a domain in part C that was that we could only use values of x that are between 0 and 5. Therefore, the largest value of x that I could have in this case is also 5. Okay, and that is because we also have to worry about the domain. We still have to think in terms of the constraints of our problem here. Okay, almost done. That's what we were asked to do to solve this inequality. We gave them the interval. We just need to explain the meaning of this answer in the context. Okay, so what does this mean? Well, the values of x that we just found, okay, in this interval, okay, in this interval, in this interval from 4.379 to 5, what's happening? Well, what's happening is that the perimeter, which is our function p of x, perimeter, okay, the perimeter of the resulting shape will be at least 45 meters. Okay, and that is it. So what this means to us is the values of x in this interval from 4.379 to 5. In that particular interval, the perimeter of the resulting shape will be at least 45 meters. Okay, and that was all that was required for this free response. Okay, I know that was to me it was a very interesting problem. So make sure that you review everything that we cover in this video. Make sure that you understand every concept in this video, and I hope you enjoyed. And any questions, don't feel free to ask your teacher. Okay, hope to see you in the next video. Goodbye.